All right, so shadows, hidden objects, all these are possible when we want to look at something with the right eye. The reason we're talking about this is because monoscopic viewing has a limitation. It's able to be able to tell depth, but stereoscopic, perception of depth is a bit different. You perceive depth by viewing from two different angles. Now the eye is the main organ for viewing, so we need to understand how the eye works. So all of you never know, I may just do it in an exam. So the pupil is an opening, okay? You need to know these things. The iris, okay, also kind of define. The iris is what people look at, and then it looks so brownish. It has a certain color. When you see a woman with a beautiful iris, you begin to look more like, wow, you go like confused. If you see a woman with a beautiful iris, the white people have this blue one. Okay, so that's the iris. Know that it controls the diaphragm. It can shrink. For cats, their iris looks interesting. People are scared of it. The optic nerve sense of vision to the brain. The optic nerve sense. So that is basically about the eye. Okay, I think we all should know how the eye works. Okay, light moves through. There's a lens. Everybody has a lens, and that lens, can get spoiled, or if you don't eat well, that it can even be damaged. Then sometimes even with age, it gets affected in terms of strength of muscle. All right, so let's understand how the eye works. It's just not there like that. If you let someone poke it, you're not going to see again. Also, the image gets recorded in the brain. So when you look at someone, you still remember the person, don't you? Because it's recorded in your memory. But really, the eye is like the camera. Okay, the eye is just like, it's what the camera is trying to mimic. So the camera also records. It focuses on the focal plane, okay, etc. So read more about it. So when eyes fix on a point, optical lenses converge on that point. The intersection at an angle called parallactic angle. No, what it really means is that when you look at an object with two eyes, there's an angle that gets sustained that helps you achieve that. What it means is that when you don't look with two, you don't appreciate that much. In other words, you'll be standing there, someone will just come in, something will be coming close to you, and you probably won't appreciate. You can only appreciate it monoscopically by looking at this changing size, shadows, and obstruction. That's monoscopic, right? The distance between the two eyes is called the eye base. Put it in your head. All right, so in this case, B, approximately most human beings, the distance between this eye and that eye are the same. It's approximately 2.6 inches, 69 millimeters. I wish I had a ruler here. I checked so you can all check your eye base. I'm sure you know a lot of this, so I shouldn't waste time. So this angle here, phi A, is the angle sustained on the object A. Phi B is the angle sustained at point B. Of course, and the farther the object is, the smaller the angle that is sustained. The closer an object is, the bigger the angle, and that relationship that is the parallactic angle. You can say this, add it to vocabulary and scare some kids with it. Is that okay? All right. So that is how it works. When you look at objects stereoscopically, then the angles are sustained. So you can see that at point A prime, we are now having different angles being sustained. So there you go. You may see the objects on the flat, represented on the image as flat, but there's a 3D virtual reconstruction of the objects. Virtual, what I mean is that the model that can be viewed. Okay, it's not real, you can't touch it, but you can see that it's looking solid. This is in the practical. You can only, so there you go. So here we go. Accurate and comfortable stereoscopic viewing is very important. That means you need to align the photographs with the axis that connect, the line that connects your eyes. Or the stereoscope that you are going to use. The stereoscopes are really devices that allow you to look at photos, stereo pairs. You just look through them like that. There are different types. Some can magnify, have magnifying glasses and all the lenses in there. Okay, so first, make sure you are aligning them very well. Okay, it's very important to have comfortable viewing. Okay, it requires the eye base, the line between the centers of the two and the fly line to be parallel. So you can't be looking at, turn your head like this and be looking at the photographs going in another direction. So we come to one of the most important things that we should have, like I said, I should have done this before the stereoscopic, parallax, but it's okay. Since you understood the idea, we can still talk about this. We come to what we call vertical exaggeration. Okay. So you hold on a second. I'm coming back to you. All right. So vertical exaggeration is the disparity in the vertical and the vertical and the horizontal scales. Are you okay? All right, the disparity between horizontal and vertical scales. Simple. Meanwhile, the ratio, are you okay? The lack of equivalence between the base to height. When you measure any base, eye base, divided by the viewing distance from the eye to the model, compared with exposure station distance between the two, air base and then the flying height. That disagreement, that disparity is what is causing the vertical exaggeration. So we can look at stereoscopic causes of vertical exaggeration: viewing distance, separation of photographs. Are you okay? Separation of photographs, eye base. Okay. Like I said, magnification as well. All right. So now the image you see here, if you change the vertical exaggeration, you tend to see the model kind of seems more 3D. In fact, this is what you do a lot in GIS when you actually want to look at 3D, a scene, what we call a scene, S-C-E-N-E. All right. So well noted, someone reminded me that my recording was off. I'm back on. Photographic causes, photographic scale, altitude above terrain, airbase terrain. Okay. So we are back to the diagram as I was talking about before I switched the recording back on. When you look at it closely, we are just playing around with a point A on the ground, which is projected onto the datum at a point at C. Are you okay? And then we have K, all right, lying on another point. Are you okay? All right. Now, so we can draw a similar diagram, and then there are commonalities. One of them, the focal length is different for the camera, and it's different from the focal length of your eye. Are you okay? Air base, eye base. Okay, so let me get my pointer. Air base, eye base, different, but there's something that's common on the photograph. Okay, we can have SK, XC, XA. They seem to be similar. Are you okay? In a way. So of course, you're going to just look at that. You look at Z over here, which is the height of the point above datum. Same way in the model. So here we have a model. It's the ground. And then we have the model. So the eye. So you can see that the eye sees the model. The ground is looked at by the camera. Are you okay? So the camera is up here. The eye is here. Okay. All right. All right, so here, as usual, we prove by looking at similar triangles. Similar triangles are necessary for every geometric engineer. So there you go. We can establish this relationship here. So here, so we can have the change. So you can see that this ratio here, Z over Z, is actually comparing the different heights, okay? The ratio between what the eye is looking at. So that's scale. Are you okay? That's scale. So there we go. We can now write this. Let's move on to the next page. See something that we are missing. All right. We can also prove that this D over D is FH over HI. What's the interesting thing about that? We are just comparing the distance. Okay, so D in the diagram. Okay, so D is a distance between K and C, which are actually on the datum. I'm trying to get my, I just want to, from here to here. Okay, so this D, that's bigger D on the ground. All right, so we can write that relationship. So vertical exaggeration is actually looking at the relationship between D over D and then Z over Z. Okay. So if I capture this, so I'm going to get this onto the whiteboard. Okay, so when you look at this relation, all right, you will see that Z over Z should be equal to D over D. All things being equal, what it means is that the vertical scale is equal to the horizontal scale. So horizontal scale is distance on map over distance on ground, distance on image space over distance on ground space. All right. So small z over bigger z. There are two different things altogether. I call small d over bigger d. It should be, but it's not. So the change is what we want to actually figure out why we don't have that. The reason we don't have that is because of the attachments, the factor BH over H1 over this one. This is the reason. This whole lot here. Okay. So BH over H, so H prime is flying height, BE flying height. So this factor should be 1. All things being equal, or should approach 1, but it's not. So we want to call that the vertical exaggeration. Is the reason for the disparity. Are we okay? It's the reason for the disparity. So vertical exaggeration is approximately equal to BH over H prime over BE. Air base. So you know what the terms are. B is air, is I base. H is the height, viewing height. Okay. So H is not the height of a point above the 2. In this case, H is the viewing height. And then B is the air base. H prime is it. So here we go. So we go back to it. So now that is why V is approximately B over H. So if you look at it, a few things that you need to know as a photograph, someone who's studying photogrammetry, this diagram is very important. You'll be needing it for several calculations. Is okay. Distance between, or the format or the photograph is D. Are you okay? 23 centimeter format photograph, D. Are you okay? That means like the dimension of the photograph. Do you get that? So we have, there's one thing you need to know. D is like the size of the photo. Are you okay? So if I were to print out the photo taken from L1, I will get this. The dimension will be D by D, and it means this is D. All right. But on the ground, I will have capital D. Okay. Now D over D is scale. So scale is also D over D, same as scale is F over H. All right. Oh, sorry. I should be writing G here. All right. Sorry about that. So the ground coverage, okay, you could call it anything, but I think J is a form, the actual standard thing that we do. Now we have flying height H, are you okay? And then focal length of F. So F over H is equal to D over G, are you okay? Not over D, D over G. All right. So typical values for the ground distance, well, could be anything in terms of maybe kilometer, maybe some hundreds of meters, 300 meters, 500 meters, kilometer or whatever, depend on the height, flying height, 800 meters, 1,000. So don't expect flying height of 30 meters, 10 meters, like an airplane won't fly at that height. So in exam, your answer should look correct. All right, the dimension of photographs are like 23 centimeters. They don't go any far from that, 100 centimeters, going too far. Are you okay? All right, so we can look at also the percentage enlap and then the airbase in relation to B and G. So we have a situation like this. If this is B, if distance is B, the air base okay, so if this is B, then geometry tells you that two parallel lines, are you okay? J is the ground distance. Okay, so it means this distance is J minus B. Okay, so this relationship too should be taken into consideration. Remember that there's a percentage enlap. Okay, we have 10 minutes. When it ends, let's probably join for the last time, then we close. So percentage enlap, maybe 60% times G is actually equal to J minus B. Okay. All right. So we should be able to write relationships like this. When we go back to our PowerPoint, so 60% of the total G, D, B, so we can do this. We can also write that B is that, I mean, like I said, F over D, H over G, these relationships can be written anytime, at any time we can, right? But we can also derive B over H. Okay, so we can say B. So here it's a very tricky thing. You take, if B is equal to J minus that, and H is FJ over D, we can write this relationship. All right. I don't know if you get it. Let me use my annotation to show you. I don't want to go proving this one again, but this whole thing, let me just get it. This thing here, okay, is B, and this is H. So B over H is equal to this divided by that. Then the J will cancel itself out. So you are left with FD, okay, which you are actually seeing here. You're left with the D, okay. J is gone. Okay. Then we have the 1 minus PE, okay, at the top, okay, because B, so J is gone. Then we turn upside down the F and the D, D over F. So we can write this relationship. Okay. So for any particular photograph with known percentage enlap and dimension, we can literally find B over H. Why are we interested in B over H? Sure, excuse me. I should have paused the recording before sneezing. All right. Why are we interested in BH? Because vertical exaggeration formula is B over H times H over BE. BE is the distance between your eyes, and then H is your viewing distance. We cannot always calculate that, and it depends on the individual. Whilst B over H now becomes the only thing that cannot easily be found, but we've now found an expression for it. So how do you work an example like this? So we know the focal length, we know the format, okay, square format 23, so 23 by 23, 60% enlap. Okay, so if you go back here, we can quickly 60%, put 60% in here. So 1 minus 0.6 times D over F. Okay. So B over H is equal to 1 minus PE over 100 times D over F. So let me just move this aside. Times D over F. So 60% is actually 0.6. So 1 minus 0.6, which is 0.4 times 23 centimeters, 10 into millimeters, 23, 230 millimeters over 153.2 millimeters. Millimeter cancel millimeter. So it's a ratio. So that we don't have any units at all. 0.4 times. Of course, you can calculate this value and use it. So we are left with what? The B over H, or H over B. Are you okay? H over B. H over B. Okay. Which we can assume for the person, whoever is looking at it. Okay, so B over H then becomes 0.6. Are you okay? And we can assume BE over H. So you can measure your own IBs and work out what that is. You are good. Okay, so hold on a second. Pick up. All right. So yes, this is it. You should appreciate this simple calculation, all right, and be able to do it if you are asked to do it. Make assumptions if you need to. So understand it. It's not about just calculate it. It's understanding it. Today, a lot of apps are available. A lot of apps are available today. So remember that anything can be calculated, but you need to understand it. Understanding it is the most important thing. All right, great. So that's it. All right, so I think we are done. We are done with this one. Do you have any question? I think we are done for this one. Do you have any question on vertical exaggeration and the way it was done? Excuse me. So I want to change the topic. Do you have any question on this? Do you have any question? Guys, do you have any question? Do you understand it and do you think you appreciate it? I don't want any funny answers. If you give me any funny answers, I'll give you funny marks and we won't have any discussion. Okay, it's a very serious thing. If you have a question, you can ask me. I'll just address it. So we are going to look at briefly. Let's talk about. Excuse me, my dry throat is back. Maybe you can look at tilted photograph. Since we just finished having a look at excuse me, to say vertical photography, look at stereoscopic viewing. Let's look at tilted photographs so that we don't go too far away before we come back. We would now touch on the ground control points, rectification. That will be very short lecture, and then finish up with project planning. So we have these two things to talk about. So we are going to look at vertical photography. So what is, oh, we have 1 minute to finish this session. We'll join for the last time. Is that okay? After this, please, let's join again. It's going to finish. So please, let's rejoin.